Welcome back, students, to the lecture video series on manufacturing process, plastic deformation theory. In the previous lecture, we discussed about the two types of deformation, which is elastic deformation and plastic deformation. So, with the help of the stress strain curve, you can see that initially in any material, elastic deformation occurs. So, the extent of elastic deformation will depend upon the ductility of the material. So ductility is the ability of the material to be stretched into a sheet, whereas malleability is the ability of the material to be drawn into wire. So these two properties play a vital role in the extent of elastic and plastic deformation. If a material is ductile, then it will have considerable amount of elastic and plastic deformation. Whereas if we take a brittle material, there will be just small amount of elastic deformation, and then there will be no plastic deformation occurring. So this stress strain curve which you are seeing is for the ductile material. Whereas if you take the stress strain curve for a brittle material, what will be there is there will be only this particular slope, which will also be smaller in size, and there will be no yield point because there is no room for plastic deformation in a brittle material. What happens is that once elastic deformation occurs, then sudden breaking will happen. When you stretch a brittle material, for example, you take the example of a glass. When you stretch it, minute elastic deformation may be there. But what happens when you stretch the glass? It will break suddenly. So sudden breaking is the characterization of a brittle material. So when a material breaks suddenly, you cannot use it in a load-bearing application. Imagine another example for this brittle material is cast iron. Imagine you are using cast iron as a shaft. So a shaft made of cast iron is used in a load-bearing application. When you start to run the shaft, initially it may run, but when you increase the load or sudden load is applied, what happens is that the shaft will break suddenly. So when it breaks suddenly, then the failure of the entire component takes place, which is very, very undesirable. Sudden breakage will always cause, imagine you are using the shaft in a two-wheeler or four-wheeler. What happens if sudden breakage happens in the middle of the road? Then it will be catastrophic. So that's the reason we are not using brittle materials in load-bearing applications. Only ductile materials can be used in load-bearing application because even after elastic deformation, there will be plastic deformation, and after plastic deformation, you will have a process called as necking. So necking is formation of smaller part, and then what happens? Fracture happens. So it is a time-consuming process, and it is a clearly visible process. Whereas if you take a brittle material, it is a sudden process. That's why for load-bearing applications, you are using ductile material. So this stress strain curve is for a ductile material. Initially, elastic deformation happens, then yield happens. So yield is the point where plastic deformation starts to happen. Once plastic deformation starts to happen, there is a process called a strain hardening. So strain hardening is nothing but because of the change in length. So strain is nothing but change in length. When the change in dimension happens, material tends to get harder. So that hardening process, which is also an internal property, is called a strain hardening. At that particular point, hardness of the material tends to increase. Strain hardening can also be called as work hardening. And after strain hardening, what happens is that necking takes place. So necking process, right? So during the necking process, what happens is that the material will form like this. Imagine you are applying load like this. So tensile load is applied. So this is L. So when the load is applied, what happens? Initially, the metal will be like this. So this will be 1. This will be 2. So after particular point, after plastic deformation, after a certain point, what happens is that the material starts to stretch like this. So after that, even more stretching will happen like this. And at the end, what happens is that fracture takes place. Material starts to fail. So this is a gradual process which happens in a brittle material. But if, sorry, which happens in a ductile material. But if you take a brittle material, there will be no such necking. After elastic deformation, sudden crack will happen, which is a very, very undesirable property. So this is regarding the plastic deformation theory. I hope you understood the plastic deformation theory. So we'll further continue the plastic deformation theory in the next lecture video, and we will also discuss about the cold working and hot working process. Thank you.